Let's take a look at a coin. A coin has the correct symmetrical shape. And if we start tossing a coin, then we have no reason to believe that some side of the coin will fall out more often than the other. Let it be necessary for us, or, as they say, a favorable event will be the fall of heads on a coin. In the theory of probability, the event will be denoted by capital letters. In total, when tossing a coin, we have only two options. This is the fall of heads or tails. What is necessary for us, or a favorable event, is the fall of heads. 1. We divide one by the other, and we get the probability of the event A. Once again, we will divide favorable events for us into the total number of possible events. At home, I did an experiment and tossed a coin 10 times, and I got heads only 7 times. I divide one by the other, and I get the probability. Somehow this probability is not very close to what we calculated, using reasonable logical arguments. But what happens if you toss a coin not 10 but several thousand times? Englishman Carl Pearson tossed a coin 24,000 times, and the coin fell to one side 12,012 times. We divide one by the other, and this number is already very close to the probability that I calculated here. And if you toss a coin further, an even larger number of times, then the resulting number will get closer and closer to the probability of the event A. And this drop is called the relative frequency of a random event. Now let's look at a dice. A dice has 6 numbered faces. And let's calculate the probability of a 1 falling on a dice. The dice also has the correct symmetrical shape, and we have no reason to believe that some face will fall more often than another. Therefore, the total number of possible outcomes will be equal to 6. And there is only one favorable event for us. We divide and get the probability. The value of the probability cannot be more than 1, since the number of favorable events cannot be more than the number of possible events. And on the other hand, the value of the probability cannot be less than 0. 0 is when an event cannot occur, or an impossible event. For example, falling on the dice number 7 is an impossible event, since there is no 7 on the dice. And here I divide 0 by the number of possible events and get the probability. And this is of course equal to 0. 1 is when we get a favorable outcome for us in any event. For example, let the event be the fall on the dice of the number less than 7. On the dice we have any number less than 7, so in this case we get 1. Now let's calculate the probability of falling on the dice of an even number. Let me remind you what an even number is. An even number is divisible by 2 without a remainder. We have only 3 such numbers. I divide by 6 and get the probability. I hope you understand that I have reduced this fraction and divided the numerator and denominator by 3. I got 1 second. Now let's complicate the task. Now let's make the problem more difficult. We roll the dice twice, and we need to calculate the probability of getting a 7 in 2 throws. I will write out pairs of numbers whose sum will be equal to 7. The first number is the first roll, the second number is the second roll of the dice. And now I need to swap these numbers. Since the numbers in the throws change places, but the sum remains equal to 7. And now I need to find the number of possible pairs of numbers that can be formed from these numbers. I can put any of the 6 numbers in first place. I can also put any of the 6 numbers in second place. I multiply 6 by 6. And this will be the number of possible pairs of numbers that can be made from the first 6 numbers. The number of events favorable to us, or pairs of numbers we need, is only 6. I divide 6 by this product and get the probability, getting a 7 on a dice in 2 throws. Let's consider one more problem. We take out one card from a deck of 52 playing cards. What is the probability that it will be a picture card? There are 52 cards in a deck of cards. And this is the number of all possible events. Picture cards, 4. And there are also 4 card suits. We multiply and divide. And the product in the numerator is the number of cards with a picture in the deck of cards. 52 in the denominator. I will write it as a product of numbers. 4 in the denominator and 4 in the numerator. I can cancel out it and I'll be left with 4/13. Another problem. In triangle DE is parallel to AB. And AB is 3 times larger than DE. Find the probability that when we randomly select a point from triangle ABC, this point will be inside triangle DEC.